In this episode, we're going to treat the supply chain as part of your system, because that mindset change is where real risk reduction begins. When beginners hear supply chain risk, they often picture trucks and warehouses, but in cybersecurity, the supply chain is the collection of people, companies, components, and processes that create the software and hardware you depend on. The moment you install a library you did not write, buy a device you did not build, or rely on a vendor update you did not control, you have extended trust beyond your own team. That trust is not automatically bad, because nobody builds everything from scratch, but it does create exposure. The software development lifecycle, SDLC, is where you can manage that exposure deliberately, because the SDLC is where you choose components, integrate them, verify them, deploy them, and maintain them. If you handle supply chain risk early and continuously, you reduce the chance that a hidden weakness from someone else becomes your incident. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. Supply chain risk in software starts with a simple reality. Modern applications are assembled, not handcrafted. A typical system might include open-source libraries, third-party services, container images, build tools, deployment platforms, and pre-built modules that save time. Each of those pieces can contain vulnerabilities, can be configured unsafely, or can be replaced with a malicious version if your acquisition path is not controlled. The risk is not only that a component has a bug, it is also that you may not know what is inside the component, or you may not be able to patch it quickly when a bug is discovered. A beginner-friendly way to think about this is to imagine cooking with ingredients you did not grow yourself. If an ingredient is contaminated, the meal is contaminated, even if your kitchen is clean. Supply chain security is about checking ingredients, choosing trusted sources, and having a plan to respond when a supplier has a problem. Hardware supply chain risk is similar in spirit but different in practical details. Hardware includes devices, network equipment, storage systems, and even the chips inside those devices. The risk can come from counterfeit components, insecure default configurations, weak firmware, or compromised manufacturing and distribution processes. Hardware problems can be especially stubborn because replacing physical components takes time and money, and because some hardware is difficult to inspect deeply once it is deployed. Beginners sometimes assume hardware is inherently trustworthy because it is physical, but physical does not mean safe, and a hardware weakness can create a long-term security gap. The supply chain also includes the vendors who provide updates, drivers, and firmware, because those updates are part of the lifecycle. When you place hardware into your environment, you are also accepting an ongoing relationship with the vendor's patch process and support commitments. Good supply chain thinking asks, before purchase, whether that relationship is reliable enough for the security you need. Handling supply chain risk in the SDLC begins with requirements and selection, because what you choose determines what you must defend later. Early on, teams should define which kinds of components are acceptable, what security properties they must have, and how they will be supported over time. For software, that might include expectations about update frequency, vulnerability disclosure practices, and the ability to track versions used in production. For hardware, that might include expectations about firmware update availability, secure boot features, and documented support timelines. This is not about demanding perfection. It is about avoiding silent liabilities. If you pick a component with unknown maintenance, you might inherit abandoned code that accumulates unpatched vulnerabilities. If you pick hardware with weak vendor support, you might end up stuck on old firmware with known weaknesses. By setting selection requirements early, you prevent the most painful outcome, which is discovering too late that your system depends on something you cannot secure. Once you select components, the next supply chain risk is integrity during acquisition and integration, meaning you receive what you think you received and you integrate it in a controlled way. Attackers love the spaces between a trusted source and your environment, because those spaces are where validation is often weak. If your team pulls a dependency without verifying its origin, or if build scripts accept unverified inputs, an attacker can potentially insert malicious code into the build. Even when there is no attacker, Careless integration can create risk, such as using overly broad permissions for a third-party service or enabling optional features that expand attack surface. Supply chain risk is often amplified by automation because automation spreads changes quickly. That is normally a benefit, but it becomes a danger if the automation trusts the wrong thing. A mature approach treats acquisition like a controlled doorway, where items are checked before they enter, rather than like an open window where anything can be tossed in. Assurance is the word we use for the confidence that a component is what it claims to be and behaves as expected, and assurance is never a single action. It is a collection of practices that include evaluating a supplier, verifying artifacts, testing behavior, and monitoring for changes over time. Beginners sometimes expect a stamp of approval that makes something safe, but real assurance is more like building confidence through repeated evidence. You might start with supplier reputation and transparency, but you also look for documented security practices, responsiveness to vulnerabilities, and clear maintenance processes. Then you add technical assurance, such as verifying that builds are repeatable, that releases are signed, and that you can trace what version is in use. You also add behavioral assurance through testing, because even reputable components can have vulnerabilities. Assurance is not about distrust for its own sake. It is about acknowledging that your security depends on many parties and proving that dependency is reasonable. A key part of assurance for software supply chain risk is version control, because security is tied to what is actually deployed, not what you intended to deploy. If you cannot reliably answer which versions of key components are in your environment, you cannot respond quickly when a vulnerability is announced. That delay is where attackers gain advantage, because public vulnerability information often triggers scanning and exploitation attempts. In the SDLC, version control means pinning dependencies so updates do not happen invisibly, and it means having a controlled process for upgrading. That process should include testing and review, because an update can fix a vulnerability but also introduce breaking changes or new weaknesses. The goal is to move fast without moving blindly. When teams do not manage versions, they often drift into a state where nobody knows what is running, updates are feared, and risk accumulates. Good supply chain handling turns updates into a routine quality activity instead of a crisis. Testing for supply chain risk has a slightly different flavor than testing your own code, because you are testing assumptions about external components and their interactions. You want to know whether a dependency behaves safely when given unexpected input, whether it handles errors in a way that leaks information, and whether it introduces insecure defaults. You also want to test the integration points, because many supply chain incidents are not about a component being malicious, but about a component being used unsafely. For example, a library may be secure when configured correctly, but insecure when left at defaults. A third-party service may be safe when scoped narrowly, but risky when given broad permissions. The SDLC should include checks that focus on these high-impact integration decisions, because that is where supply chain risk becomes real risk. Testing helps you identify where you must add compensating controls, like input validation, access restrictions, or extra monitoring. Hardware assurance and testing include additional concerns because hardware has physical and firmware layers that can be hard to inspect. Still, beginners can understand the basic approach. You validate that devices come from authorized channels, you track where they are deployed, and you ensure firmware updates are applied and verified. You also test hardware behavior in the environment you plan to use, because a device can be secure in isolation but risky when connected to a broader network. Hardware components often ship with default credentials, default services, or default management interfaces that must be locked down. Supply chain risk here includes both the risk of compromised devices and the risk of ordinary devices deployed with insecure defaults. A disciplined lifecycle approach also includes monitoring vendor advisories and planning maintenance windows for firmware updates, because hardware security is not a one-time event at purchase. It is an ongoing responsibility that must be part of operational reality, not an afterthought. One supply chain topic that deserves special attention is the build and delivery pipeline, because it is the factory where your software is assembled. If that factory is compromised, an attacker can insert malicious changes that look like normal releases. Beginners sometimes assume attackers only target production systems, but supply chain incidents often target the creation process because that path scales. A compromised build environment can distribute malicious code to every user in one clean-looking update, which is far more efficient for an attacker than hacking users one by one. That is why you protect the build pipeline with strong access controls, separation of duties, and careful handling of credentials. You also want strong traceability, meaning you can connect a release back to the exact source and process that created it. When traceability is weak, you cannot confidently answer whether an artifact is legitimate. In the SDLC, protecting the factory is as important as protecting the storefront. End of life, EOL, is where supply chain risk becomes unavoidable if you ignore it, because EOL means a product is no longer supported with security updates. Beginners often treat EOL like a purchasing problem, but it is a security requirement problem and a lifecycle planning problem. The moment a component reaches EOL, known vulnerabilities may remain permanently unpatched, and attackers know that. If you still depend on that component, your risk grows over time, not because you are doing something new, but because the world around you keeps finding new weaknesses. Handling EOL well means tracking support timelines, budgeting for upgrades, and designing systems so replacements are feasible. If your architecture makes upgrades painful, you will delay them, and delay is how EOL becomes a chronic security issue. A good SDLC includes EOL planning as a normal part of maintenance, not as an emergency later. There is also an important integrity angle to EOL because unsupported systems often force teams into risky workarounds. When updates stop, people may disable security features to keep compatibility, or they may expose systems in unsafe ways to keep them accessible. They may also rely on unofficial patches or unknown sources, which can introduce new supply chain risk while trying to solve the old one. This is why EOL is not just a date on a calendar. It is a pressure point that can distort good security decisions. The best time to handle EOL is before it arrives, by planning migration paths and testing replacements early. The second best time is immediately after you discover you are already past it, by isolating the component, tightening access, and accelerating replacement. Either way, the lesson is that ongoing support is part of your security posture, and unsupported components weaken that posture in ways that are predictable and preventable. Supply chain risk management also includes governance, meaning clear ownership and accountability for external components. Someone must be responsible for approving new dependencies, evaluating vendors, tracking versions, and monitoring vulnerability reports. Without ownership, supply chain tasks become invisible work that nobody prioritizes until something breaks. A beginner might assume the development team handles dependencies while the security team handles security, but supply chain risk crosses those boundaries. Development chooses components and integrates them, operations runs them, security assesses risk, and procurement may sign contracts. If these groups do not share a common process, risky components slip in because each group assumes someone else checked. A resilient SDLC makes supply chain handling a standard workflow with checkpoints, documentation, and feedback loops. That reduces the chance of surprise and speeds up response when something changes in the external world. When incidents do happen, supply chain readiness shows up in how quickly you can answer basic questions and take decisive action. Can you identify where a vulnerable component is used and what versions are affected? Can you deploy an update quickly and safely? Or are you afraid it will break production because updates are rare and untested? Can you isolate a risky system while maintaining critical functions? Or is everything tangled together? These are not theoretical questions. They determine whether a supplier vulnerability becomes a minor maintenance event or a major breach. This is also where assurance and monitoring meet, because you want signals that indicate abnormal behavior after an update or signs of compromise in a component. The best supply chain programs expect that suppliers will have issues sometimes and focus on reducing blast radius and response time. Preparedness turns uncertainty into manageable risk by making action possible when time is tight. To tie everything together, handling supply chain risk in the SDLC means treating third-party software and hardware as first-class parts of your threat model and your engineering plan. You start with selection requirements that prioritize maintainability, transparency, and support because those qualities drive long-term security. You maintain integrity during acquisition and integration by controlling how components enter your environment and how they are configured. You build assurance through evidence over time, not through a one-time trust decision, and you use testing to validate both component behavior and integration safety. You protect the build and delivery pipeline because it is a high-leverage target that can amplify harm. You plan for EOL so unsupported components do not become permanent vulnerabilities, and you assign ownership so supply chain tasks stay visible and consistent. When you develop these habits, you stop treating supply chain risk as bad luck and start treating it as a normal, manageable part of building secure systems.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.